Hello, this is Fadi Al-Fayoumi giving a presentation on nanotechnology as an emergent technology. Nanotechnology is defined as the manipulation of matter on an atomic and molecular scale for fabrication of macroscale products. It's defined by the National Nanotechnology Initiative as the manipulation of matter with at least one dimension size from 1 to 100 nanometers. The US has invested more than $3.5 billion in it, same as for the European Union and Japan. In order to understand the unusual world of nanotechnology, we need to get an idea of the units of measure involved. A millimeter is 1,000th of a meter, and a micrometer is 1,000,000th of a meter. But all of these are still huge compared to the nanoscale. A nanoscale is 1,000,000th of a meter, smaller than the wavelength of visible light. As small as a nanometer is, it is still large compared to the atomic scale. An atom has a diameter of about 0.1 nanometer. An atom's nucleus is much smaller. Atoms are the building blocks for all matter in our universe. You and everything around you are made of atoms. Nature has perfected the science of manufacturing matter at the molecular level. For instance, our bodies are assembled in a specific manner from millions of living cells. Cells are nature's nanomachines. On the nanoscale, we can potentially put these atoms together to make almost anything. One of the exciting and challenging aspects of the nanoscale is the role quantum mechanics plays in it. The rules of quantum mechanics are very different from the classical physics taught by Albert Einstein, which means that the behavior of substances at the nanoscale can sometimes contradict that of macroscale. For example, substances that are insulators, meaning that they cannot carry electrical charge, in bulk form might become semiconductors when reduced to the nanoscale. Currently, scientists find two nano-sized structures of particular interest, nanowires and carbon nanotubes. Well, let's talk about carbon nanotubes. A carbon nanotube is a nano-sized cylinder of carbon atoms. Imagine a sheet of carbon atoms, which would look like a sheet of hexagons. If you roll that sheet into a tube, you would have a carbon nanotube. Carbon nanotube properties depends on how you roll the sheet. In other words, even though all carbon nanotubes are made of carbon, they can be very different from one another based on how you align the individual atoms. With the right arrangement of atoms, you can create a carbon nanotube that's hundreds of times stronger than steel, but 6 times lighter. Engineers plan to make buildings material out of carbon nanotubes, particularly for things like cars and airplanes. Lighter vehicles and airplanes would mean better fuel efficiency, and the added strength translates to increased passenger safety. Unlike many other technologies, nanotechnology has potential applications in virtually all areas of human life, including health and medicine, energy, information and technology, material and manufacturing, and the environment. It is this cross-cutting nature of technology that gives it the potential to make a big impact on environmental quality and sustainability. Nanotechnology may have its biggest impact on the medical industry. Patients will drink fluids containing nanorobots programmed to attack and reconstruct the molecular structure of cancer cells and viruses. There is even speculation that nanorobots could slow or reverse the aging process, and life expectancy would increase significantly. Nanotechnology has the potential to have a positive effect on the environment. For instance, scientists could program airborne nanorobots to rebuild the thinning ozone layer. Nanorobots could remove contaminants from water resources and clean up oil spills. There are many barriers and challenges. The most immediate challenge in nanotechnology is that we need to learn more about materials and their properties at the nanoscale. Closely related to the knowledge barrier is the technical barrier. In order for the incredible prediction regarding the nanotechnology to come true, we have to find ways to mass-produce nano-sized products like transistors and nanowires. There are also some hefty social concerns about nanotechnology too. What if the technology goes wrong in one way or another? Nanotechnology may have the potential to change the way we look, live, behave, and interact with the environment around us. The challenges are many. Most important is how to make it positive technology and avoid potential disasters. Thank you very much.